Hello. It's only been a couple of days since I uploaded the last video, but I've managed to get a bit of a wiggle on. Got a bit of the bug and put some more code together. So since the last video, I found and fixed a minor bug in the assembler. It wasn't anything major. It was just to do with one of the variables was remembering something between each iteration, and it shouldn't have been. I've rewritten the screen handler, and we'll go through that in a minute. I've added some pseudo ROM code. It's not actually ROM, obviously, but it allows us to test printing out to the LCD screen, the pseudo LCD, the pretend LCD area within the NCurses window environment. I've added another file called define.h. This just allows me to start adding names to parts of the 6502 memory map. Really makes life a bit easier to understand. You'll see that as we go along. Okay, so we used this slide in the previous video. It's just sort of a bit of a refresher of how we've got the screen set up. Now the LCD screens, the way they work in real life is that they've kind of got two registers. One register is the data register, and they can be 8 or 4 bits. Ours is 8, and they've also got an 8-bit data register, which is I've decided to set up like this. So bit 7 says there's something to do. So if bit 7 is clear, there's nothing to do. The screen handler doesn't do anything. If bit 7 is set, then there's something to do, and the rest of the bits tell it what to do. So you've got clear screen, print a character, invert a character, move the cursor, and how to move the cursor. Now the invert a character and move a cursor stuff, I haven't done any of that. So the only routines that have been written is the clear screen and the print character. So within the array, our memory array, I've decided that hex 1000 and hex 1001 are going to be set up as the two registers for the screen. So inside of fsm.h, under the execute function, once we've executed the 6502 instruction, which we've done many times, we've seen it in previous videos how that works, we call the screen handler, and we saw that in the last video. And the screen handler uses these two areas here to decide what it's going to do and how it's going to do it. So the screen handler checks if there's something to do by checking bit 7 in hex 1001, and if there's something to do, then it does it, else it doesn't do anything at all. So the process for the 6502 codes, if you think about it, when the emulator is running, we're actually running a 6502 instruction set, and our 6502 instruction set manipulates what it sees as memory and what our emulator sees as an array. So inside of our 6502 program, the first thing we need to do is load something into the accumulator, and in this case we're going to load the hex number of 41, which just happens to coincide with the ASCII value of 65, which is the ASCII value of A, which is a decimal value of 65. So then what happens is within the execute function, it comes along and once it's executed that LDA, as we said before, it then runs the screen handler, and the screen handler says, have we got something to do? Well, no, because bit 7 isn't set. So step 2, store the accumulator into the screen data. So we store the value of 41, hex 41, into area 1000. Remember, area 1000, 1000, we've designated as the screen data register. So that's where the screen picks up what it's going, the value it's going to use. So the screen IO then goes and checks for something to do, and bit 7 still isn't set, so it still doesn't do anything. Then we load the accumulator with 1 to 8 plus 32, and if we sort of reminisce a little bit, a couple of slides, and it's down here, 1 to 8 says there is something to do, and 32 says we want to print a character. That's the something we want to do. So what we do is we load the value of A0, and A0 happens to be the value of 160 in decimal, and we put that into the accumulator, and the screen IO checks for something to do. Well, we've not done anything with it. We haven't popped it into memory yet, so there's still nothing to do. So now what we do is we store the accumulator into what we've called the ELCD register. We store that into 1001, and then the screen IO checks to say there's something to do, and it says, oh yeah, there is something to do this time, because the value now is A0, and A0 is 160, which is 128 plus 32, and the something to do is this. So the screen handler then comes along and says, okay, first thing I'm going to do is I'm going to make a temporary copy of the data. So it takes that value of 41 and pops it into scr_char, and it makes a copy of A0 and pops it into scr_reg. And this is the if statement that says, is there something to do? Yes, there is. And then the first thing it does is it clears the LCD register here, so it flips it to 0, so that when it drops out the bottom in a little while, the next time round, unless we've set it specifically, it will not do anything again. And these are the if statements that says, if bit 6 is set, then we clear the window. If bit 5 is set, then we print the character that we've copied into screen character up here. And as you can see, the other routines aren't written yet, but they would work in a similar fashion. And the result of all that is a capital letter A up at the top left of our pseudo LCD screen. And this is a bit of ROM code, or pretend ROM code, because there isn't a ROM, it's just an array. Of course, at the moment we can write to it if we want to, but we'll do something about that at some point. Now then, at location FE00, we had a look at this last time, we've got this string asterisk 6502 space EMU and asterisk. So that's our 10 character string starting at FE00. So what does our code do? Well, our code does exactly what we've just outlined in the previous slides. It loads the index register X with a 0. It loads the value from FE00 indexed by X. Well, index, add 0 to FE00, you get FE00. So it puts 2A into the accumulator. It then stores 2A into our data area for where the LCD screen is going to pick it up from, and 2A is the representation for asterisk. We then load A0 into the accumulator, and A0, as we said, is the hex value for 160, which is 128 plus 32. We store that into the register, and we INX. But for each and every one of these instructions that runs, the screen handler, so once it's run this LDX, the screen handler would look and say nothing to do. Once it's run the LDA, it would say nothing to do. Once it's run the STA, yeah, nothing to do. Again, nothing to do. Now after this STA here at FF1A, it would say, yes, I do have something to do. So at this point here, it would stop executing instructions for a moment. The screen handler would come along, and the screen handler would chuck an asterisk out to the pseudo LCD screen run by NCurses. Then once that had finished, remember 1001 would now have a 0 in it, because the screen handler clears that flag, clears that register. INX, so it increases X now equals 1. It compares X with A. Well, 1 doesn't compare with A, so it branches back. Now F2 is the negative values, remember, so it's minus 14 bytes, so that sends us back to FF12, and FF12 then says, I'm going to load FE00 plus X, so that's FE01, and it loads the value 36, and it goes through this entire process up until the point where X equals A. Once X equals A, that BNE no longer matches, and it does an RTS. Okay, so let's see what that looks like on the screen. So if we just at the moment, we know that if we hit go, oops, I need to be on the actual thing there. So if we hit go, it runs. Brilliant. What's it doing? So if we reset the machine, and we're back with the program counter here at FF04. So what we'll do, there is our string and here is our code. Well, actually that's the comment for the code, but this is the code obviously in hex, right? So what we'll do is we'll run that one at a time so that we can see it happening. So what should happen? It should load x with 0. Well, x is already 0, so if we step, first of all what it'll do is it'll jump to ff10, which is where our code starts. So ff10 is here, and the reason it does that is because on ff04 it's a JSR to the print screen on ff10. We covered that slightly last time, but I thought I'd reiterate it. So now it'll start to do the code inside of there. Now we've done the LDX, but as you can see, the X there is already 0, so it doesn't look like anything's happened, but it has, because our program counter is increased to FF12. And FF12 will load the contents of FE00, and FE00 was up here, FE00 is here, so it'll put 2A into the accumulator. So if we step, we should end up with 2A in the accumulator, and we do. So there's 2A. The next thing then it does is it stores A into our data area of of hex 1000. So if we actually memory dump of hex 1000, we'll see that at the moment it's got 20 in it, which is decimal value of 32. That just happens to be a white space. So if we step and then we memory dump that 1000 again, we'll see that it's got the 2A in it. So that command there, that store into the hex 1000, that's worked lovely. So now what we'll do, if we step again, it loads A0, and then we step again and it will store that A0. So if we do a memory dump of the register, in fact it's as you can see there, it's 0. Why is it 0? Because it's run the screen routine, it's put the asterisk on the screen, and as you remember, the first thing that the IO function does is once it says, is there something to do? Yes, there is. It clears that register. Okay, so that's the way I wrote it. It kind of works for me. So the next step, we'll go again, and we'll watch the compare. So it's actually run it's increased x by 1, because that was the INX command there. So it's INX. Now it's going to do the compare. Okay, it's done the compare, and now it branches. And there's the branch back to FE12. Okay, and if we do several quick successive steps, you'll see it print the 6. There's the 6. And then it'll go in there again, increments x to 2. And then we'll run the step again. It'll branch next time round. There we go. And then we do 1, 2, 3, 4, and there's the 5. Yeah, there it is. So what that's proven is that our the new code that I've put in here, in here, is now functional. So that for me is a far better way of handling the screen, because we can pass it off to a different piece of code. We can manipulate that different piece of code to do something, and that piece of code is handled, as we said, from inside of this this execute routine up here. And inside the execute routine, every time so there's the go, which is the while loop we've discussed in previous videos. It runs the screen handler after it runs every instruction. So there's the actual instruction. Then it runs the screen handler, and it bombs round and round and round up until done. On a step, well, it just gets the current instruction, it runs the current instruction, and then it runs the screen handler and drops straight out, and then pops you back to the where are we? And then drops you back into main, where it came from, and main will then run you back into the into this bit here where it puts you back at the prompt. I've also changed this actually, because what I did was I put an if statement around here, so this entire bit of code here is now encased in an if. So if basically if you don't put any input in, it ignores all of this code, so it doesn't even bother. Checking for tokens or going through the switch case statement. It just says don't do anything, push you straight back at the prompt, and I found that much more effective. It's a lot cleaner, without having to put all sorts of conditions around the actual input string. You just check the input string's valid, and if it is, then you do something, and if it isn't, don't bother. And of course at the bottom here you've got the refresh for the main window there. Okay, so that's pretty much it for this video. It's just a very, very simple outline of the fact that we've actually got the screen handler doing something. The register window obviously works because you can see the registers are updating. The main window works, scrolling works as it did before, we've actually got code in that that now prints something with inside of the emulator to that screen. So that's basically the update from the previous time, and we've managed to get NCurses doing a little bit more better functionality than it certainly was with the screen handler last time.